Good afternoon, Math 7 Honors. This is Ms. Brunel, and today we're going to be reviewing the order of operations. And I say review because I know most of you have studied the order of operations before, so if I go a little fast, just feel free to pause or to rewind the video, watch it again, make sure that you understand exactly what to do with the order of operations. So, what are the order of operations? Well, the order of operations are rules that we use to follow when we are simplifying an expression that contains multiple operations. That's exactly what we use. And many of you have learned about PEMDAS, which is an acronym that we use to remember what the order of operations are. Some of you have even learned about GEMDAS before. And GEMDAS is really the most appropriate acronym to use. So we start with G, and G literally means that it is the grouping symbols. Now, there are many different kinds of grouping symbols that we use, and many that you're familiar with already, such as the parentheses. And you have seen absolute value. Yes, absolute value is a grouping symbol. And what you'll also be seeing this year a little bit, and more so when you get to algebra, are you've seen braces, or you will see braces, and you'll also see brackets. So those are the grouping symbols that you'll be often seeing in class this year. So that's G of GEMDAS. The E stands for exponents. And it also includes radicals, which we've been discussing. The M and the D are for multiplication and division, multiplication and division. And they go on the same line because you actually do the multiplication and division in whichever order it comes in the sentence, in the expression. So in other words, you do multiplication and division in order from left to right, whichever comes first. This is also true of the last letters in our acronym, A and S. This stands for addition and subtraction. And again, we do that in order from left to right. So now that we've got that in our notes, let's go ahead and do a few examples. The first two examples are actually pretty simple examples, but let's go through them together. Now, you may have heard from a teacher before, and this is something I really try to emphasize with my students, is that as you're doing a problem like this, as you're evaluating an expression, as you work, you'll show each step of the order of operations, and you'll work coming down. So it almost becomes like your work forms this inverted pyramid as you work through a problem, with your final answer being circled or boxed in the bottom. So let's see if we can make that happen here. So we have 7 plus 54 divided by 3 times 2. Well, what we'll be doing is we'll be doing our multiplication and division first in order from left to right, which means the 54 divided by 3. So we have 7 plus 18, not an ampersand, 7 plus 18 times 2. And underneath that, we would do multiplication next. So we would have 7 plus 36. And now we can do addition and subtraction from left to right. In this case, we have only addition. So 7 plus 36 gives us 43. And you can see we have that inverted pyramid. I didn't do a great job landing in my circle there. So let's get us a new circle to show our final answer and make it clear for everyone that 43 is our final answer. Let's look at number 3 now together. In this case, you should see that there's exponents, but you should also notice that there is a grouping symbol here. You have absolute value. So we're going to go ahead and we're going to keep our exponent there. I'm going to write it as 9 with this little caret, the 2. That's another way to express exponents. So it's 9 squared plus 28. Now, instead of using that division symbol, which many algebraic teachers hate, I'm going to use a backslash to represent division, or like a fraction. So 28 divided by 4. And now I can find the absolute value of negative 18, which is the distance from 0. So that's 18. So I'm going to write minus 18. Now I I can go ahead and do the exponents. So 9 squared is 81 plus, again, I'll write 28 divided by 4 minus 18. My next step is to do the multiplication and division part of the acronym GEMDAS. So that would be the 28 divided by 4. So underneath here, I will have 81 plus 7 minus 18. And now I can add and subtract from left to right. So 81 plus 7 is 88 minus 18. And finally, my answer to this problem would be 70. I'll go ahead and I'll circle this answer so that it's clear. And you'll notice here that we have a nice inverted pyramid that shows all of my steps in GEMDAS in the order of operations. So I'm going to now ask you to turn the page because it gets a little bit more complicated on the back. I'm not sure if you've ever seen a problem that looks like this. Look at number 9. Actually, 9 and 11. Both of those, and 10, have fractions. There's a fraction bar here. Remember, a fraction bar means division. When we have a situation like this, when we have expressions like this, you're going to go ahead and you're going to use the order of operations individually on the numerator and then on the denominator, and then you will finish by simplifying as much as you can. So let's take a look and see what that actually looks like as we're working. So I'll start with number 9 and look at the numerator. I see that there's exponents there, so that's going to be my first step. 4 cubed is 64, so I'm going to write 18 minus 64 plus 25. I'm going to go ahead and I'm going to write a fraction bar for us using this tool. Sorry that it's not perfectly straight. And then I'm going to work the denominator aspect of this problem, and I see that I have exponents in the form of 5 squared. That would be my first step. So I'll do 28 minus 25. So now we move on to the second step, and we're going to be, it looks like there's no multiplication and division in the numerator or the denominator, so we'll go ahead and look at the addition and subtraction portion. Again, we're working from left to right. So 18 minus 64 is negative 46. I'm going to write plus 25. I'm going to go ahead and I'm going to draw my fraction bar. Again, that means division. And then underneath that, 28 minus 25 is 3. So we can further simplify that. We can do the numerator some more. We have to add still. So negative 46 plus 25, that would give me negative 21. I'm going to go ahead and make my fraction bar. And negative 21, and on the bottom, we will have 3. And I think that we can simplify that a little bit further. I'm sure you guys see that we can as well. So negative 21 divided by 3 would give us an answer of negative 7. And I'm happy with that. I'm going to go ahead and I'm going to circle. Now, I could have also written negative 7 underneath here to show my further inverted pyramid in the succession of my steps. Okay, let's take a look at another problem at number 11. So it's getting a little bit more complicated. We have exponents, we have grouping with exponents, we have multiplication, addition, and subtraction. But again, I'm going to go ahead and I'm going to start with my numerator, and I'm going to do grouping symbols first. So I would write 2, can't see that, hold on, I'm hoping this moves, yeah. 2 to the 7th, I'll rewrite that. I'm going to do my grouping symbol first, so minus 3, and that's to the 3rd power, plus 3, and we will draw in our fraction bar, and we'll look at the denominator next. In this case, I will be doing the multiplication first, so I will do 12 minus 7 times 2, which is 14. But now I'm looking at the numerator again. I see I have all these exponents that I have to contend with, so that's my next step. So 2 to the 7th is 128, and I subtract 3 cubed, which would be 27, and I add 3. I'm going to go ahead and draw my fraction bar in again, and look at my denominator, and 12 minus 14 is negative 2. And And now I can further simplify the numerator. It looks like we need to subtract and then add left to right. So 128 minus 27 plus 3 will give me 104. Again, I have to draw in that stupid fraction bar again because I don't have a way to do it otherwise. And we have negative 2. And now I can do 104 divided by negative 2. And I'll end up with an answer of negative 52. Remember, we always circle our answer when we're done to show our teachers our work. That didn't want to circle. Let's try that again. Circle our answer. And there we have it. And again, you can see there's an inverted pyramid there showing every step of the order of operations. Okay, for homework tonight, what I would like you to do is, if you need to, go back and watch this video, but I want you to finish the rest of these problems, be ready to discuss them tomorrow, to check our answers, and if you have any questions, as always, please remember, bring them to class tomorrow or post them below in our Google Classroom.